Alright, everybody. Welcome back to video time with Mr. Thornburg. Excuse me. Now, there's a couple things that I want to make sure that we have clear here. This is going to be a real short video, but I want to make sure I give you your homework that we're going to do tomorrow in class, and that also I include your little thing you need to take care of at the end of this so that you get all your points. So, let's get started with this. First thing we want to talk about is the zero and negative exponents. Those are going to be the two properties that we're going to learn today. Both are pretty gosh darn important and pretty simple once you understand what you're doing. Okay, so let's just get my pen working here. Come on, there we go. Where you at? Alright, here we go. Alright, so zero and negative exponents. I don't know why hold on one second. There we go. Alright, zero and negative exponents. The zero exponent property, basically all that it says, it's pretty straightforward, is that for every non-zero number a, so any number, that's what this is saying right here, any number a to the 0 equals 1. This is what the property is actually telling you. Okay, there we go. Alright, so it means any number, any non-zero number, as long as it's not 0, any number that I take to the 0 power is 1. Okay, so for example, 4 to the 0 power is 1. Negative 1 to the 0 power is 1. 13 to the 0 power is 1. Negative 81 to the 0 power is 1. This looks like 13 million to the 0 power is 1. And then you can see I picked a really big negative number. Negative 1,458,215 to the 0 power is 1. Okay? And the y is the important reason. That's what we're going to talk about here. The y is... when we're talking about exponents, you have to remember how they work. You have 3 to the first power, which is really just 3, right? And if I say 3 to the second power, you can tell me that that is 9. And where do we get that from? Well, we get it from 3 times 3, all right? Then if we go back to 3 to the third power, we end up with 27. And again, we get that from 3 times 3, and then we multiplied it by another 3. Okay? Again, and we can continue on with this and continue to go. 3 to the fourth power is 81, and we got that from 3 times 3 times 3, and then we added on another times 3. Okay? So each time we're just adding or multiplying by another 3. Okay? So if we go backwards, instead of multiplying by another 3, if I want to move up the chain, so to speak, then I'm actually dividing by 3, right? So if I go from 3 to the fourth to 3 to the third, I'm dividing by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So it should be no shock that exponents only talk about multiplication and then division. Multiplication as they get bigger, division as they get smaller. Alright, closer to 0. So then we have this kind of issue of, well, what happens when we do 3 to the 0 power? Well, patterns should maintain, and as they do, we find out that 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So 3 divided by 3 is 1. Alright? And that's some of the math that's behind this right here, okay? So just remember that your exponents are only talking about multiplication and division depending on which way you go. We usually only deal in algebra with the multiplication side, but you need to be aware of the division side when we go backwards, just as for to some of the properties that we're going to deal with. Alright? So that is why, but this is the important part right here. You need to know that. There's going to be a lot of questions on your homework about that. Alright? Let's talk about one more. Negative exponent property. For every non-zero number, a, again, non-zero, so a cannot be 0, and integer n Now remember what that means. When we talk about integers, all we're talking about is it has to be not a fraction or not an irrational number. It has to be an integer. We're talking about the set of integers, any number, any whole number, but also including all the negative whole numbers. Okay, so negative whole numbers, that's not really a word, but hopefully you can understand what I mean. Examples are 1, -3, 6, any of those numbers work out fine. Okay, so I need a to be any number that's not 0, and I need n to be an integer. So here, a is 2, it's not 0, and n is 3. So 2 to the -3 equals 1 over 2/3. -21 to the -8 equals 1 over -21 to the 8th. 1 over 9 to the -5th equals 9 to the 5th. Do you see what's happening here? Do you see the pattern? Let's try one more. 3 over -7 to the -3rd is 3 times -7 to the 3rd. Okay? Hold on 1 second. Alright, if anybody picked that up, another teacher just walked in here and started talking to me. Alright, back to what we were talking about. So, the only thing that's moving is the base, that is to the negative exponent, alright? And it's moving up every time. Now, this might be going through your head right now. And what you need to realize is that the negative sign that we use so often has a couple different uses. One, right, we use it for subtraction. Okay? Like 7 minus 3 equals 4. This is one of the uses for the negative sign. Okay? A second use for the negative sign. Opposite. Okay, and we've been doing this for a while too, alright? The opposite of 8 is -8. The opposite. That negative always tells us look for the opposite. Okay, and we use that with polynomials. I mean, we use that a lot. All right, so now you have this third new use. Okay, third use, and it's with exponents. Okay, reciprocal. Okay, exponents. Put that in parentheses. Okay, that's not a statement, so we better put that. All right, and what that says is 2 to the -3rd says I want the reciprocal of 2. What's the reciprocal of 2? It's always fraction, okay? So this is 2 over 1, so the reciprocal will be, you flip it, 1 over 2. I want the reciprocal of -21. Well, that's 1 over -21, and we lose the negative, okay? I want the reciprocal of 1/9. That's 9. Okay, again, we're just flipping it. Now, I want the reciprocal of 1 over -7. Notice I did not say 3's -7 because the 3 is not taken to the -3rd power. The 3 is on its own. Only the -7 is taken to the -3rd power. So only the -7 is going to flip. Alright, last one. I want the reciprocal of k. Alright, well that's 1 over k. And I want the reciprocal of s. Alright, well that's s over 1. Or 1 over s. So it's s over 1. Okay? All we're saying is reciprocal. If it's below, it moves up top. If it's up high, it moves down low. Pretty straightforward, and we lose the negative. It does not affect negative numbers like this -7. The -7 is still -7. It only affects negative exponents. Okay? Finish up, and your homework for tomorrow is going to be page. Well, it's on 7.1. I didn't write the page number down. I was trying to give this to you guys to be nice, and I completely botched that. It's 7.1, and it's 9 through 65 odds. 9 through 65 odds. All right. I will see you tomorrow. Peace.